Today's episode is sponsored in part by Palo Alto Networks and its Prisma SASE, where AI-powered innovation takes center stage. Watch the new Palo Alto Networks virtual event on demand to hear how the latest innovations in SASE can help your organization. See how ZTNA 2.0, Cloud Secure Web Gateway, and SD-WAN deliver exceptional security and ROI. Watch on demand at paloaltonetworks.com/engage/SASE-signature-moment.
Welcome to Heavy Networking, the flagship podcast of the Packet Pushers Network. Conversations by engineers for your professional career development. I am Ethan Banks. With me is Drew Conry Murray. You can connect with us on LinkedIn. And today's discussion is with Matt Horn. Matt's a network architect who's going to share his experience using Terraform to stand up a data center network. Yeah, Terraform. We didn't say Ansible. We said Terraform. Matt was able to automate a variety of platforms, including Cisco ACI, iOS XE, and NXOS, F5, and Palo Alto Networks. Not only was Matt able to use an infrastructure as code approach, he was able to leverage pipelines where certain events would trigger actions in the network build. Oh, and Matt did this build mostly remotely. So wrap your head around that one, folks. This mighty use of Terraform was not without its challenges, so this is one of those conversations where you can learn how someone else solves some difficult problems so you don't have to solve them yourself. Matt Horn, welcome to Heavy Networking. And hey, man, this is your first time on the show, so just take a second and introduce yourself to people.
Yeah, thanks for having me. I'm just a longtime network, guy who's done a little bit of everything in the space, and I'm all about automation these days, so thank you for having me.
So we were talking, I think, in Slack. I lose track of where we were chatting, Matt. I think it was Slack, though, about this project. This is a cool project. Could you talk about this data center project? What were you standing up the data center to do?
Yeah, so this was going to be a new backup data center. We call it a OOR, out of region data center. So it's outside of where our primary geography is. And, we're standing this up to be the place where we host all of our backup infrastructure. We do try to do everything in a, where we have an active passive at a minimum, if not active for all of our applications. And this was going to be our new, backup facility for everything that lives in the data center that's, not also already in the cloud.
So it's essentially a BCDR kind of setup where if something goes wrong at data center 1, things can migrate over and fail over to data center 2.
Exactly.
So data center interconnect, that kind of thing, or was it truly kind of a cold DR?
No, we have DCI, so there's, multiple circuits in between the data centers. We use, F5 GTM to kind of, do traffic steering so we can silo things depending on where the workloads are. And sometimes we use it for testing, right? When we want to do testing of, some change in the infrastructure application, we can shift it over to the, to the backup site where we can test that, thing in a very controlled manner and then, shift it back when we're ready to, have it back in the production data center.
In the intro, Matt, I mentioned a bunch of the OSs that you were working with. Can you talk a bit about the like Cisco ACI and F5? There's a whole mix of stuff in here. You just talk at a high level about what that architecture is?
Yeah, sure. So, we have a lot of Cisco in our infrastructure. So, a lot of Cisco route switch on both the iOS XE platform as well as NXOS. And then for the main part of the data center fabric, it's Cisco ACI. We're running F5 for the load balancers and GTMs, as I mentioned, and then Palo Alto for our firewalls. So, we have a fairly complicated mix of vendors, and obviously with the mix of vendors comes a lot of support challenges around how they play together and how you can holistically manage those things. So but overall that was the design that we stuck with. We weren't choosing too many new technologies for this data center build. We were sticking with mostly things that we are tried and true. It was just this is really a new mode of operation with this infrastructure as code approach that we took.
So this means the primary data center is also Cisco ACI, iOS XE, NXOS, et cetera?
Yeah, there's mostly, the firewall platform is different there. So there were some differences, but, this data center I'd like to say that we kind of simplified the design a little bit. We've been trying to do that over time, and get rid of some of the additional complexity we had in our existing production data center. But this design seems to have suited us well with, the platforms we chose.
So the elephant in the room, of course, is Terraform here. Most network automation shops, if they're using that sort of an automation tool, it's Ansible. You're using Terraform. Why Terraform, Matt?
Well, I don't want to give the impression that we don't use Ansible for sure. We use Ansible a lot within our environment, but the choice to use Terraform was one that wasn't. I'll say it wasn't entirely our decision, from the beginning. There was definitely a very strong preference from upper management to use Terraform. A lot of that came from we use it for a lot of our business application deployments already, right? So, they were trying to kind of, keep this consistent pattern where, we're using the same tool sets as much as possible throughout the organization. So, Terraform is fantastic for, deploying to cloud environments and, things where you have this, central management plane that you can just hit one API and everything works. So we had some reservations, around using Terraform because, the physical infrastructure we're working on isn't, doesn't always play that well, at least not, some platforms compared to others. So, but in the end, I think it was the right decision. It turned out to be a really nice way to manage our infrastructure. So, we found ways to make it work, and I think we'll get into those ways here as we continue on.
So, a quick question, because it sounds like this came from the top down, and my association of Terraform is primarily with public cloud. Is the idea here to be sort of bringing that public cloud model into the on-prem data center operationally?
I think we're eventually we'll get there. Like I think where you're driving at is like the ability to, self-service request of things, right?
Right.
We're not
Yeah.
quite there yet. That is on our roadmap. That's something we want to get to. I think our what we were driving at here more was to adopt infrastructure as code first of all, right? I think that's kind of almost a table stakes you need to have to be able to get to that self-service. You have to have some way you're kind of holistically defining the infrastructure before you can let people just kind of willy-nilly request what they want. So it was really the infrastructure as code was a piece. And that was the thing that, like, even though we knew Terraform might be a little bit of a challenge on some of our platforms, infrastructure as code as a whole, that ideology was something that we really, really wanted to adopt.
And I think the impetus of my question was it wasn't just like management was like, we already got the Terraform licenses, so we're using Terraform. There's also a strategic input behind this decision as well, in that this is the way we want the organization to move going forward.
Yeah, I think that there was some of that. I think there's just a strong preference. I also think that there was maybe not necessarily like a complete understanding of, how you could, use a tool like Ansible to accomplish something similar. It was just they'd seen it done with Terraform and it worked well throughout. So I think there was kind of almost a bias to go that route.
How did you find the Terraform providers for the gear that you were using? Were they right up to date, well supported by the vendors? What was your experience?
It was a mixed bag. Some of the providers, the APIs have kind of personalities, right? So like the way that they behave, that some handle, deploying an existing resource better than others, where they'll just kind of adopt it or override it. But, we also had some that were just, the provider was new because the hardware platform was new. Like I'll give you a specific example. Like we were working with F5 and our account team was awesome. They were very supportive of what we were trying to do, but we were using their new Velos hardware. And, it's kind of like a abstraction, right? Where you kind of have these physical layers and like physical tenants, and you split up the resources. And they have a very good Ansible collection, but they didn't have a Terraform provider that was publicly released yet. So like we were trying to, we were an early beta tester and testing it out, and in the end, it wasn't ready for us, right? Like it didn't, I think that if I tried to do it today, it probably would work, but it wasn't there and ready for us. So that was somewhere we had to kind of, choose an alternate path. But higher up in the stack in F5, we were able to use the big IP provider that was very feature rich and capable. So it really varied on the platform and then the level of complexity for the things that we were trying to implement.
Yeah, did you end up filling in the gap with Ansible then? Because you mentioned you did end up using Ansible on some level.
We used Ansible for some of them, so that's what we did for the Velos platform. Some of the providers also have things that were kind of nice, like on the Cisco iOS XE and NXOS platforms, they give you like a generic REST provider, right? So you can manage any REST capable object the API supports, but they might not have like a true like native resource for it, that's built specifically to manage it. So, that there's certainly, depends on what the provider's capable of doing. So we did find ways to do things that the provider didn't wholly support, with like a nice native feature.
So talk to us about state files then. You're standing up an entire data center, lots of gear. Did you split up a bunch of state files over the repo? How did you manage them?
Yeah, so we started out with this approach where we were going to have one repo per platform. Just made sense to split them up that way, at least initially, because like while it's a whole data center, it's not like a massive data center. So we have, between all the platforms, maybe 100 devices or something like that we were going to manage. So we split them up by platform, and so yeah, we were using the Terraform remote state functionality of GitLab, and we stored, the backends on GitLab. And then what we found out over time is we kind of ran into some challenges around, scaling. Some of these platforms, like thinking about like a switching infrastructure where you're going to have thousands and thousands of ports, across all the devices, you run into this problem that like when Terraform's doing its check, it's got to like pull every single one of those to compare it with a state file. So, we would run into this situation where if you're running a plan, it takes, 10 minutes to run a plan before you can deploy something like a simple, up-down interface state change or change into VLAN. So what we ended up finding out is we got to split these things up even more, which, gave us the advantage of reducing the blast radius. And then it also shortened our the time it takes to actually implement changes.
So how did you decide to divide them up into smaller units?
So we're already doing it by like physical location, right? So like, we were kind of planning from the beginning, each site would have its own state, but then what we're breaking it up further is kind of by zones. So like we have like a management plane, we have a DMZ plane, we have trying to think what some of the other ones are, like a cloud edge. So we split them up kind of based on how we kind of logically structure the zones of our data center.
But still with specific devices also tied in there. So you didn't separate by function. It's all you've got zones, and then within that, you've got individual devices that are in that zone that you would have a state file for.
So they were still split up by platform, right? So like, we might have had, for example, like in a DMZ zone, right? We'd have a firewall and then maybe a couple of routers that were, attached out to the internet. So there was, if you're looking at it from that perspective, there was actually, two state files. There was a state file for the firewalls that'd be in that zone, and there'd be a state file for the the routers that are in that zone. It was just because we didn't intermix like the Terraform code between platforms.
Yeah.
So for people like me who aren't deeply familiar with Terraform, how would you compare the idea of a state file to the idea of configuration?
So what we actually ended up doing with it is we separated. So like, Terraform has this concept of infrastructure as code, and you can kind of write it out, and it's like looks a little bit like JSON if you're going to structure it in like a TF-vars file. But we actually took a step further in abstracting it. So we created intent data files that were, YAML or CSV files that were, very easy to interact with for our operations folks. And it let them, have an easy way of like not having to know Terraform to be able to, go and update the configuration. And we would read that into our Terraform code with they have these YAML decode or CSV decode functions, and then it would pass it into the Terraform as, variables or whatever we were using it for, or locals. And so that was, we treated that almost as much like the state, right? So like Terraform has its own state that it's, kind of doing to compare your HCL with what's deployed, but it gave us that abstraction so that people could, it was more of like we thought of it like a product. How can we deliver this automation so that people can consume it? And by, giving a nice data model and some documentation around like what all these fields and everything mean was how we accomplished that.
Well, it's an abstraction of an abstraction, right? You got an abstraction of the state file, which is an abstraction of the API or however the device is being configured by Terraform. So,
yep.
Yeah, we're really far from the device now. Yeah.
Yeah, exactly. But in the end, it was the only way that we could make it really approachable. Like we have people that really do want to learn automation within our group, and but it's not just as simple as learning some Terraform, right? Picking up a tool and learning it. There's a lot of other concepts that go into it. So we wanted to think about like, how can we make this as approachable as possible? And, the intent data model is something that seems like it worked really well for us from an adoption standpoint.
But you have to maintain that other abstraction level on top of Terraform?
To a degree, yeah. So like if we want to add a new feature, for example, right? Like, we're supporting something new that we want to do in the configuration. So we'd have to develop it in the Terraform code. then also develop it in our intent data, right? And like document what that looks like from an endpoint perspective. And then, also, make sure people are aware of that, right? So we do release notes whenever we roll out new features, but that's that's definitely, as you start building on top of things, it kind of, you run the risk of building a house of cards if you're not careful with it. But so we have to be really strategic around, how we develop features and then roll them out.
Is it fair to say that you built an orchestrator?
It's not. I think we want to get there, but I wouldn't necessarily call it that because to me, orchestration is like when you start building like multiple platforms together and like, if you're going to deploy an app, you have firewall rules and on one platform and maybe routes on another and that sort of thing. And we don't have that level of complexity yet. It's really just, we're still kind of device centric in how we're configuring these things, where when I think of orchestration, I think of that as more of a higher level holistic approach. So
like a service catalog kind of thing. Like
yes.
I want to stand up a VPN service that might involve routes and switches and firewalls and so on, and you got to deal with all of those different devices. You're not doing that as such. You're just making it easier for a device to be configured. And people don't have to know HCL. They don't have to be able to deal with Terraform itself. They're a level away from that with the data models you built for them.
Yeah, exactly. And it helps with the execution time. And, it's like, so when we want to build a new VLAN or something, right? You update it once the intent data, and then it's going to deploy it consistently every single time, and it's also going to, happen quickly, right? Like, so if you're doing like a single port change, you might be able to log into that. But if we wanted to turn up, 100 ports across however many different switches, for some new application or system we're going to support, like you can, build out the intent data once, and then during your change window, it takes, just the time to run the Terraform plan and apply to actually deploy it.
So did you have to lay groundwork with the engineering team on this model and this new approach to standing up infrastructure?
Oh yeah, absolutely. So we have like our automation group, we have, the engineering group, and then we have operations. So it was very much a collaborative effort. We were working with the engineering, subject matter experts, for each of the platforms to understand exactly like what does the baseline configuration for whatever, platform, and then maybe the type of device that we were deploying. So they really helped us define what that looks like. And then, with those requirements, we went and built the Terraform code to deliver the type of solution that they wanted in the configuration.
Let's pause the conversation for a message from sponsor Palo Alto Networks. 2023 is a year when companies are going to need to do more with less. As businesses grapple with economic uncertainty, it's more critical than ever to consolidate fragmented security and networking solutions to reduce operational complexity and costs. Palo Alto Networks has a new virtual event on its Prisma SASE, where AI-powered innovation takes center stage. You can watch this event on demand and see how ZTNA 2.0, Cloud Secure Web Gateways, and SD-WAN deliver exceptional security and ROI. Hear how the latest innovations in SASE can help your organization automate costly and complex IT operations with AI-powered digital experience management, connect and secure branch offices and the hybrid workforce with SD-WAN, ZTNA 2.0, and Cloud Secure Web Gateways, and unlock better ROI through consolidation of point solutions with Prisma SASE. Watch this event on demand at paloaltonetworks.com/engage/SASE-signature-moment. That's paloaltonetworks.com/engage/SASE-signature-moment. And now back to the podcast.
Well, let's get to the remote configuration aspect of this. I mean, every time I've done any kind of greenfield new stuff, it's been on site. In fact, there was one of the data center projects I was on. I was like the second person in the building because we were staging switches, racking them, and all of that. But you're doing this remotely. Now, there had to be some kind of remote hands. I understand that. No, you can't. There's no robots to rack the stuff for us yet. But walk us through that remote configuration aspect. You had no network at all, as I understand it, from what you told me, and yet you got this thing all stood up without. Did you go to the data center at all, Matt?
I was never in the data center, so we had we worked with a vendor that helped us do like all the rack and stack and cabling, and it was a lot of work, just like coming up with the cable mapping and everything for them. But like, so they did a lot of that physical hands-on work, and then we had like one guy that was in the region of that data center who he spent a lot of time there, and it was helping, like, if we found that there was a cabling that was missed or something like that, and he would go out and, help us fix that. But it was definitely a challenge. It was a big logistical thing of like trying to think about the dependencies, like what all do I have to bring up first? Because the way we approached this is we got the circuits up for like the routers that connected closest to the edge. And, we kind of built out, we had all the Terraform intent data built out for the devices, but we kind of had to drop it in a very careful, controlled manner, and originally we were targeting like the management, the WAN facing interface that was like connected back to our existing data center. And so we kind of worked backwards that way. And I guess before I get to that point, we have this, what we consider bootstrap configuration, right? So it's like the bare minimum configuration to put on a box to get it up, configuring the management interface, a local account, enabling the REST API. There's like a handful of things like that. Just the very basic, because like, and this is stuff that we consider that we won't manage with Terraform. It's, it's just something that needs to be done physical on a device, like through a console. And I know there's ways you can kind of do that with some of the console solutions, but we didn't have one to do that. We do have an out of band management for console, but not with like the automation capabilities. So once that bootstrap configuration was on, then we kind of worked our way backwards. We started at those routers that were closest to the edge until we got our what we call sideband management network. So it's not completely out of band. It still uses the data path, but it does sit off to the side of like the core the fabric of the data center. So we kind of worked our way backwards and just kept dropping in, one device platform at a time, depending on what was reachable, until we had it all built out. And then, once we had that sideband management network set up, then we were good to go, because pretty much everything else had its management on those set of networks in there. But yeah, it was certainly a logistical challenge to try to work through and think through, like, how do you do these things remotely without the connectivity you'd need to the runners.
Well, it feels like a Lego kit. You've got the Lego box, everything's in there. All your pieces are in there. All your state files are in there. But you got to work through the instruction book, one step at a time to actually build this thing. And at the end of it, you go through one dependency at a time, and then you've got it all stood up. So yeah, and you start at the edge. That makes sense, because how else would you do it? You get your connectivity from the WAN into those edge routers. You could jump from there and then, work your way in. Did you end up with an out-of-band network?
Yeah, so we do have a completely out of band network that we can use as well. So that's kind of like our break glass scenario. So ideally, all the changes going forward are done, everything with Terraform aside. There might be a handful of things that come up here and there where we're like, the provider doesn't support it, or we haven't written a resource specifically for it. So we might have like cases like that, but the automation should do pretty much everything, and then the out-of-band management's really there just like in emergency situations. We've had to use it, unfortunately, already, like where we've had situations where, you got to get in on the console of a device and you don't have any connectivity to it, and, it's got the LTE backups like a lot of them have now. So we could, get in and, bang out some commands on the console to bring things up if we need to.
Another thing you talked about when we were exploring this offline, Matt, was you talked about pipelines. Can you talk about when and why pipelines, and then what tools did you use? Get our heads around that.
Sure. So when we first started deploying this, we were just we were kind of rushing to get a solution in. So we were just using a Linux box, running some Terraform, and just running the commands locally on the command line. And we still do that to sometimes when we're doing need to debug things or whatever, but we realized that we needed to have a way for our operations people to consume this, and we didn't want to have them all logging into Linux boxes and trying to remember all the right commands to run, and changing to the correct directories to run everything in, and even learning how to use Git, right? Like learning how to do a Git pull or check out the right branch, deal with whatever, those Git issues that, everybody runs into and has to Google for from time to time. We wanted to abstract that from them. So, because we're using GitLab for the code repository, what we ended up doing was I mentioned we have Ansible, so we kind of set up some integration between GitLab and Ansible. That's a webhook occurs whenever you do a merge request, and that the merge request is kind of like our key point. So like somebody can check out or create a new branch, develop all their new code. And then when they do the merge request, that's what kicks off our pipeline. So GitLab will, make that call over to Ansible that starts a playbook that basically checks out the branch, and we have a whole bunch of checks in, but it'll run the Terraform plan and then kick back the results over to GitLab. So from our operator perspective, they can stay entirely within GitLab. So like the Terraform plan results get kicked back over as a message in the merge request. So that way, whenever they want to do the peer review before they actually, proceed to push this thing on for actually deployment, they can look at the Terraform plan, and then they can also look at all the code changes in that, that merge request. And then there's an approver from like, a handful of people that are, verified as, I say this configuration looks good. And then once they get through those stages, and they actually merge it during the change window, the second stage of the pipeline will kick off, and it'll actually go and it'll take that plan and apply it to make it everything get deployed into the environment. So it made it very approachable for our operations people to use this, and it's a very linear process for how do you make changes and verify what you're going to get as a result, and then finally deploy it.
How would changes have happened before you put in a pipeline?
With Terraform, it was just a matter of, it was a little bit more willy-nilly, so people would, log into the box and pull down the whatever branch that they were going to be on, and run a Terraform plan and, kind of work through it manually. So it required a little bit more comfort on that, working on a Linux box and, learning how to use Git and those sort of things. So we just really wanted to remove those layers of friction from people that, might not have been as comfortable there.
And what about that review stage? Would that have been in the process before the pipeline?
So it wasn't originally, but that was one of those things we keep trying to build out the whole governance around this, and trying to make sure. And those peer review process is something we've been harping on pretty hard, that, all these changes need to be reviewed. And that's how we're going to build the confidence and the knowledge with the team by, participating in the peer reviews and, seeing like, oh, this is the code change that makes this, set of, plan changes come out. So, it's kind of helping build this culture of automation in the team by enforcing that.
Do you also tie it into a broader ticketing system, or is this kind of it?
Yes, we do. So we use ServiceNow like most people do. And so right now, the way we're dealing with is, we'll have like the branch name will be called, whatever the change ticket number is. And, we make sure the merge request also references it. But we're working on actually building. We have some compliance frameworks that we do now that we, for some of our other automation with Ansible, that, we make sure that there's a change number that exists and it's in the open state and all those sort of things. So that's coming very, very soon for us. We're going to actually start to build that into our pipeline to verify that, this change that you're doing for this branch matches up with an active and open change. So it's only can be deployed during the window when it's approved.
Okay.
In the pipeline model, when there's a change being reviewed and you want to reject that change, what's that process like?
So it's basically just kill the merge request, right? You close the merge request and deny it, and then at that point, that branch just, I think when we close that, I don't remember if it deletes the branch or not, but it kind of dies on the vine there, and the main branch will continue on, and whatever new changes need to come in will they'll go through their own separate process.
So you can document in the rejection why you didn't allow that, basically didn't allow that merge request to happen, why you rejected it. And then the person who initiated would be notified that they got it wrong or something was wrong with it. And then what, they start anew?
Yeah, exactly. So, and so, yes, that's a good point. So like, if you wanted to reject it for whatever reason, you could do that, and that'll close the merge request, but the existing branch they were working on will still be out there. So the same case would happen. Like, let's say you did the, you made your code changes and you run the Terraform plan and it comes back with like, let's say an error message, right? You had the stinking YAML formatting got me again, right? I didn't have a space where I needed a space or something like that, and so, the pipeline will kick back whatever error that we got, in the message. So we already have it now. So if the plan fails, it'll actually close the merge request automatically, but it does send email notifications. So, whoever submitted that merge request will get notified that, this plan failed or whatever. And then they can go back and make their change again in the same branch that they were working off of, resubmit the merge request, which will, trigger that whole process to start again. And hopefully they, fix their spacing issue or whatever it was. And, their plan comes out and looks good. And then they do the peer review process and go from there.
They'll have a copy of that YAML file sitting locally that they would have synchronized up to the repo. So it's not like they lost any work when you rejected them and shut their branch down. You're so mean, Matt.
Yeah, we rule by an iron fist here.
But there's an elegance to this whole thing. I love this conversation. With the infrastructure as code approach, and the entirety of your infrastructure lives in a repo represented as code, every change that is made in the infrastructure is basically documented incrementally because of all the version control that's there, as opposed to the old days before this, where there was no repo. Code review was, these are the stanzas I'm going to bang in at the command line. And then the reviewing engineer needs to look at that and kind of understand the implications of what all that's going to do. Is this going to work? Is this not going to work? How's this going to happen? What's the implication for other things? And if you reject it, you reject it. Then you're just looking at code and it's all isolated. There's nothing, unless you know the infrastructure you're looking at, you don't have a lot of context. You gotta really, on an engineering level, understand it. And you still need to do that with what's happening here. I understand that, but you don't have this repository unless it's in your brain of what the network actually looks like and how this change is going to impact things, as opposed to now in infrastructure as code and repos, the entire network state just lives there. This is it. This is our reference. This is what the network is supposed to look like. I say supposed to look like because maybe it doesn't because reasons, but this is such an elegant thing, Matt.
Yeah, and the other benefit to that we're discovering is that because of exactly what you just described, the intent is defined, we can start to use that intent data for other things like verifying our baselines, right? We have these security baselines. We need to make sure, DNS is configured this way, or, AAA is configured that way. So we have like these defined scope of things. And now we can go and validate that. We can make sure that, we can run, something as simple as, grep in the repos to look for whatever those, configuration elements are. And then, just making sure that it's that way. And as long as you run a Terraform plan and there's no drift from those, I mean, that's a way of verifying that your configuration matches your intended state.
Yeah, you sort of anticipated my next question. Do you feel like you can use this as kind of a model to do other things, to maybe start testing changes and so on against your intent and what the reference should look like?
Yeah, that's an area that we're exploring right now. So we have what we call secure baselines, right? And for every single product in our portfolio that we support, there's, InfoSec requirements, that align with all of these, industry standard things. We have a lot of compliance to deal with because of our industry. So, there's a lot of these things that we need to be able to like validate and prove. So, we're thinking about ways to do that. And where we have the Terraform in place with the infrastructure as code, it's fantastic. We're trying to figure out ways to deal with that in brownfield too. But we think if we can take the same, that infrastructure as code methodology, we can still pull the same way that we define what does a secure baseline look like. And then, even using a tool like Ansible and be able to go out and, query that stuff that's not managed by Terraform yet for the same definition of what is a secure baseline. So even in the places where we're not yet using Terraform, I think we're going to benefit from that whole infrastructure as code, mindset.
Yeah, you sort of anticipated another question in that, would you want to try what you did with Terraform in a greenfield, in a brownfield environment, and where would you see the friction?
We do. We absolutely do. And I think the easy way for us to do it is going to be over attrition, right? So like eventually we have a lot of hardware that's at a point where it's close to being a hardware refresh cycle point. Mm-hmm. So as that happens, we're going to deploy everything new with Terraform. But some of the stuff that's, not so old. That's earlier in its life cycle. We've been doing some testing and trying to figure out how can we use Terraform to adopt that. And some providers are more forgiving than others. Some of them you're going to have to do like a lot of like imports to suck in all the configuration into your state file if you want to do it that way. Others are a little, easier to work with. Like some of them, like iOS XE, you can just like, you know, roll right over the top of it, right? So if you have existing configuration on the box, as long as you make your intent data align with what you want the configuration to look like, like see, you're going to define all the interfaces with their configuration, everything matches up. When you do a deploy, even if it's not in the state file, it just kind of like it'll redeploy it over the top. It's no different than like, you do a show run, copy the whole config, and then paste it in again right over top. If there's no changes, it just takes it. And even in the API, it works very similar to that on some platforms. So some places it'll be easier than others. So that's something we're definitely thinking about and how we manage that.
Now, I've been on a variety of different kinds of network teams. Some of them were quite small. Some of them were, big with dozens of engineers. If I want to build a system like this, like what you've described, it feels daunting if I'm on a small team. Like, I don't think I got enough resources and time to figure this all out, Matt. So what was did you have a pretty sizable group of people that you're working with?
Our group as a whole is pretty large. I think we have people that are not just engineers. We have engineers, operations. We have people that help support from like a governance and, managing like all the compliance stuff. So it's like about 100 people to get an idea of the size that we're with. But the group that's focused on automation was only like 3 or 4 of us. It was a small group, and then we all have, other things that we're working on too, but like automation is a big part of what we do. It's just not everything that we do. So it was a little bit of
something key there, though. You had 3 or 4 people that have a heavy focus on automation. As you said, not the only thing you do, but a big part of it. So that does indicate there's some level of focus that an IT group has to have on automation to bring it to life. It's not something you're going to knock off in an afternoon after watching a quick YouTube video.
Oh yeah, for sure. Yeah, this was definitely seeing the aggressive timeline on the project, it was a little scary at first, like how the heck are we going to pull this off? But we all worked together and made key decisions on what tools we were going to use, kind of rough structure of how we wanted to develop our automation. So we kind of had some alignment, because different people were working on different platforms, but we all had a similar way of doing the development, so that people that were actually trying to consume it later, that it was it was approachable, and it wasn't like, oh, if I want to do it on this platform it's this way, and I want to do it on that platform it's that way. So things weren't wildly different, and that was, I think, a key part to our success. We had a strategy around how we wanted to do it.
And how do you deal with the temptation that folks must have of being like, I just need to do this one thing, so I'm gonna, work around the pipeline and just remote in and do the thing, and then it'll be fine.
Well, the way we dealt with that was the harsh way. This was a new data center, so we built out everything with we use ICE for our identity management, or for AAA. Mm-hmm. So we scoped it so that all the new devices that were being deployed were in a separate set of device groups, and we built different policies to them. So anybody logging in with a named user account, they get read-only access. That was,
wow.
And now in the case of an emergency, right? Like, let's say that there's something that, the automation is broken or it's not supported. Like, we have mechanisms that you can, check out the an account with admin permissions and be able to log in. But that checkout is logged, right? So that should be only used when absolutely necessary. And then, and after the fact, follow-up needs to be done. So if something's done outside of the automation, you need to make sure that, and the team is aware of this, right? So that they have to follow up, because the next time we go to do a deployment, it's going to, good chance it's going to wipe out whatever that manual change that you did, and, potentially cause another breaking issue. So we found that that's really the only way that we can enforce, this to work. And it's not for a lack of trust. It's just it's the way that you have to do it. You have to enforce it to happen the way that it needs to go through the automation pipelines.
Yeah, those habits are probably hard to break. So you just had to Yeah. Lock the snack cabinet door and throw away the key.
Exactly, exactly.
Did you have pushback? People that were like, non-believers?
I don't think we really had pushback. It was just, I mean, maybe some reservations, but we've really spent a lot of time and effort into training and doing knowledge transfer, and there's a lot of mentoring that's happening. And so and like I talked about the peer review process before, right? Like, as we're getting like we have people we call champions on each team. So like they're the ones that are working the closest with our automation group to, understand how this works. How do you use what we built first, right? Like figure out how to use this, and then that also helps offload the burden from, like our automation team, where we have people that become, a little like a level 2 support, right? That whenever somebody runs into a problem on the team that's new to using it, they can go to that person instead of coming directly to us. And that's kind of helping, build these bonds and relationships with the team so that, more people understand how to do it. But I think the more we do that and the more exposure we get to it, that reservations around it will change. But everybody does seem to be generally kind of excited and looking forward to this new way of operating, because they start to see the benefits of it over time. And it's pretty awesome once you can see, like, I can deploy an entire router, with the exact configuration the way I wanted, in just a matter of minutes, once it's all up, and, it's pretty incredible when you actually see it in action, or when you replace a device. Like we had one of our F5s where we had to like rebuild the chassis, and this is like multiple tenants with all these different configurations, and it took us less than an hour to rebuild the configuration on this thing, like, and I didn't have to do anything other than rerun the deployment tools, right? We had to run an Ansible playbook to build out the Velos piece, and then run the Terraform to build out the the big IP side of it, and then less than an hour from the time the hardware was installed, everything was up and running. It's awesome when you see it do that.
Yeah. So you had buy-in from management then, it sounds like. So you must have had great support.
Oh yeah, the management from, like, the organization as a whole is very automation centric and focused on it, but like our network team management is just like they're drinking the Kool-Aid for sure. They really, I mean, they're really passionate about it, and it shows, because they do prioritize the work on it, and they're making sure that everybody's putting in training time towards learning these things. So they're very supportive of it, which helps tremendously.
Well, Matt, why don't you sum up for us with some highlights for folks that are evaluating Terraform for network automation, some top tips, some takeaways, things that you learned along the way?
I guess get to know your provider, right? The Terraform providers for whatever your platforms are. It's really, I think that's the crux of it, right? Do you have based on what your configuration is, that like how you build your configuration for your platforms, just look at what the providers are capable of. The Terraform registries are out there that you can kind of look at all the resources, and make sure that all your configuration is there. Because if it's not, it's going to be a nightmare, right? It may not even be possible, right? In some cases, we actually have a handful of platforms where we just can't use Terraform yet. It's not there, and it's not HashiCorp's fault, right? It's up to the vendor, right? The vendor's got to build the those providers to take advantage of it. So that's a key point. And then leverage your vendor relationships. That's where we got a lot of support from the vendors that we did implement Terraform with, and like the F5 was awesome, Palo Alto was great, Cisco was great. They were really helpful. The account teams were there and helped us navigate the process and put us in contact with the right people. So they all have evangelists for these things. Like the vendors, I mean, from my experience, the vendors want to do automation. They want to give you the right tools to do it. It's just a matter of finding them and figuring out how to do them. And usually you just got to get connected with the right person at the vendor. So I think those are probably my biggest takeaways from this. It's, it comes down to the Terraform provider. And then I guess the only other last thing I'll think is just as you're building these things, think about it as like a product, right? Think about, you're building an automation. It's not like a set of scripts. This is a new way of doing things. You think about it like a product, and like what are the inputs and what does the user experience feel like when you're doing this? So that was a big thing that helped for us from the adoption standpoint, because that intent data model and, making sure that anybody could look at this and, as long as they understand, what the structure of the data model, they can deploy the configuration they needed. And that really made, the friction much less.
I'll echo what you said about that Terraform provider and understanding that. I was talking to a friend of mine the other day. He works for a vendor, and his job right now is to write a Terraform provider for the product that he supports. It is a somewhat complex product, but he told me he's into over 200,000 lines of code in this Terraform provider right now, and he's got a long way to go. So they can be incredibly complex, it sounds like, to give all the feature support that you might want in your Terraform provider to be able to make the box do all the things that it's capable of doing. So yeah, finding the right person within the vendor to help support you is certainly a key. But those people are there. You just gotta ask the find the right person, and those people are there. They want to help you.
Yeah, for sure. And I guess don't be afraid to submit issues on GitHub for it, right? So like all the Terraform providers, if it's released to the public, they have to have a GitHub repo. And so if you have a feature request or a bug, like don't be afraid to file an issue and request a feature. Like we had awesome support from Cisco on some of these things. Like there were multiple revs to the Terraform provider that were because of a feature requests that we put in. There was a lot of things, like per VRF type of configuration, things that were like not your standard type of thing that you might see in like a smaller deployment, but big organization where we have a lot of segmentation and separation and security concerns. Like we push, we're outside the norm on a lot of those configurations. So we filed requests on or issues on GitHub for those things, and a lot of those maintainers, they do it because they love it. And, we found that, they were quick to respond in many of the cases. So, if it's not capable of doing what you need, don't be afraid to ask, because you might be surprised at how quickly you get what you're asking for.
Matt, how do people follow you on the internet?
Well, I'm not a super social guy, but LinkedIn, I'm on LinkedIn. So, I'm always open to, chats and things like that. I do occasionally share things that I, find interesting, but that's going to be the best place to interact with me.
Well, thanks, Matt. Thanks for taking the time. This is a great story. I love this. A lot of detail, you have a way of expressing what you did in such a way that it was a pretty clear picture in my mind of what was going on. So that was really great. Again, thanks, Matt, for sharing the time. And thanks to you out there for listening. I've been Ethan Banks with Drew Conry Murray. We'd appreciate any feedback or comments that you've got via LinkedIn, the Packet Pushers Community Slack group, or you can send us a follow-up via packetpushers.net/FU. That's for follow-up. Not the other thing. You can join our Slack group at packetpushers.net/community and talk to us directly if you would prefer that. Lots of other resources available to you at packetpushers.net. Our entire lineup of shows can be found there. We're adding more podcasts to our network regularly. If you only listen to Heavy Networking, which is this show, you might also like Heavy Wireless with Keith Parsons, Packet Protector with security expert JJ Manella, and Packet Pushers' very own Drew Conry Murray. We also offer several more podcasts for IT engineering professionals in our lineup covering cloud, Kubernetes, strategic IT thinking for all you architects out there, weekly industry news, and more. Last but not least, remember that too much networking would never be enough.